Hello everyone, welcome to our channel Python with GecBharuch. Myself Patel Binal. In this series, we will learn about operator and its precedence in Python. In the previous video, we covered bitwise and logical operators. Now we will be focusing on assignment, membership and identity operators in this session. After that, we will see example of this operator. First, I'll give you a clear explanation of each assignment operator. We will explore what they are and how they function. Next, I'll demonstrate how each operator works by running code examples, so you can see the outcomes and understand how to use this operator. First, let's talk about the assignment operator. This is one of the most basic yet powerful operator in Python. Assignment operators are used to assign value to variables. These are the list of assignment operators. First, assignment operator. This operator simply assigns the value on the right to the variable on the left. For example, here x equal to 10, assign 10 to x. Next is add and assign operator. This operator adds the right operand to the left operand and assign the result to the left operand. For example, x plus equal to 3 is equivalent to x equal to x plus 3. Next is subtract and assign operator. This operator subtract the right operand from left operand and assign the result to the left operand. For example, x minus equal to 5 is equivalent to x equal to x minus 5. Next is multiply and assign operator. This operator simply multiplies the right operand with the left operand and assign the result to the left operand. For example, x multiplied equal to 2 is equivalent to x equal to x multiplied 2. Next is divide and assign operator. This operator divides the left operand by the right operand and assign the result to the left operand. For example, x divide equal to 4 is equivalent to x equal to x divide 4. Next is modulus and assign operator. This operator takes the modulus using two operands and assign the result to the left operand. For example, x modulo equal to 3 is equivalent to x equal to x modulo 3. Next is float divide and assign operator. This operator float divides the left operand by the right operand and assign the result to the left operand. For example, x float divide equal to 2 is equivalent to x equal to x float divide 2. This operator divides the variable by right operand, rounds down to the nearest whole number, discarding any decimal part and assign the result back to the variable. Next is exponentiate and assign operator. This operator raises the variable to the power of right operand and assign the result back to the variable. For example, x exponentiate equal to 2 is equivalent to x equal to x exponentiate 2. Next is bitwise AND and assign operator. This operator performs bitwise AND operation between left and right operand and assign the result to the left operand. AND operation compares each bit of the variable with a corresponding bit of other value. For each bit position, it results 1 if both bits are 1 and 0 otherwise. Next is bitwise OR and assign operator. This operator performs a bitwise OR between variable and right operand and assign the result back to the variable. OR operation compares each bit of the variable with a corresponding bit of other value. For each bit position, it results 1 if the either bit is 1 and 0 only if both bits are 0. Next is bitwise XOR and assign operator. This operator simply performs a bitwise XOR between variable and right operand and assign result back to the variable. XOR operation compares each bit of the variable with a corresponding bit of other value. It results in 1 if bits are the different and 0 if they are the same. Next is write, shift and assign operator. This operator shifts the bit of a left operand to the right by the number of positions specified by right operand and assign the result to the left operand. For example, x right shift equal to 2 is equivalent to x equal to x right shift 2. Next is left shift and assign operator. This operator shifts the bit of a left operand to the left by number of positions specified by the right operand and assign the result to the left operand. For example, x left shift equal to 2 is equivalent to x equal to x left shift 2. Last is Walrus operator or assignment expression. This operator assigns a value to variable as a part of an expression. This operator was introduced in Python 3.8. It allows you to assign value to variable within an expression context. So we have covered what the assignment operator is. Let's understand it with the help of example. I am going to show you how this works by writing few lines of code in Google Colab. First is assignment operator. Here I have assigned value 10 to variable x using equal to operator. When we run this code, x will store the value 10 and when we print x, it should output 10. Next is add and assign operator. Here x start with value 2. The plus equal to 3 operation adds 3 to 2 which gives us output 5, which is then stored back in x. When we print x, it outputs 5. Next is subtract and equal to operator. Initially x is 5. The minus equal to operation subtract 3 from 5 which gives 2, which is then assigned back to x. When we print it, x is 2. Next is multiply and assign operator. Here x starts with value 5. Then multiply and equal to 3 operator multiplies 5 by 3 which gives us output 15. Next operator is divide and assign operator. Here value of x is 10. Divide and equal to 2 operator divides 10 by 2 which gives us output 5.0. Notice that division result in a float. So when we print it, x is 5.0. Initially x is 10. The float divide and assign operator calculates 10 float divide 3 which is 3. Since the division result is in float and the float division discard the decimal part, so x become 3. Next is exponentiate and assign operator. Initially x is 2. The exponentiate equal to operation raises 2 to the power of 3 which gives us 8, which is then stored in x. When we printed, x is 8. Next is bitwise AND and assign operator. Here value of x is equals to 6. In binary, value of 6 is 110. And binary value of 3 is 011. The bitwise AND and equal to operation perform bitwise AND with 3 which gives 010 which is 2 in decimal, so x becomes 2. Next is bitwise OR operator. Here also x start with 6. The bitwise OR equal to operation performed bitwise OR with 3, which gives 111, which is 7 in decimal, so x becomes 7. Next is right shift and assign operator. Initially x is 6. The right shift and assign operation shifts the bit to the right by 2 positions, which gives 0001, which is 1 in decimal, so x becomes 1. Next operator is left shift and assign operator. Initially x is 3. The binary value of 3 is 0011. The left shift and assign operation shifts the bit to the left by 2 positions, which gives 1100, which is 12 in decimal, so x becomes 12. The next is walrus operator. The colon equal to operator assign 10 to n and then immediately checks if n is greater than 5, since 10 is greater than 5. The condition is true and n, which is 10, is printed. We have covered assignment operators and see how they work in practice. Let's move on to the another important category of operator in Python, identity operators. Identity operators are used to compare if two variables are actually the same object in memory. They check if both objects have the same data type and share same memory location. Identity operators have two operators. The first is operator. Is operator checks if two variables refer to the same object in memory. It compares the memory location of the object, not just their value. For example, here both x and y are pointing to the same list in memory because we assign y is equals to x. When we check x is y, Python compares whether both variables point to the exact same memory location. Since both variables refer to the same object, the result is true. In simple terms, the is operator returns true when two variables are essentially the same entity in memory. The next operator is not operator. The is not operator checks if two variables do not refer to the same object in memory. It returns true if they are stored at different memory locations. For example, even though both x and y have the same elements, they are separate objects stored at different memory locations. Python creates two different lists, one for x and one for y. When we check x is not y, Python compares their memory location. Since they are different objects, so result is true. Now last is membership operator. Membership operators are used to test if a value is present in a sequence like list, string or tuple. There are two membership operators. First, in operator. The in operator checks if a specific value is present within a sequence like list, string or tuple. It returns true if the value is found. For example, the expression A in B checks if the character A is a part of string banana. Since character A is indeed found in banana, so result is true. Next is not in operator. Not in operator checks if the specific value is not present within a sequence. It returns true if the value is not found. For example, the expression x not in B checks if the character x is absent from a string banana, since x is not found in banana. So result is true. Thank you for watching. I hope this video helped you to understand assignment, identity and membership operator in Python. The lecture notes for this series available in description below. Make sure to check them out. I'll be covering operator precedence in my next video. So stay tuned. See you in next one.